So now that you're aware that API is the way two applications or programs actually communicate with each other, so what should be a gateway then, isn't it? As mentioned here, it's an opening that can be closed by a gate, and in computing terms, it is a device used to connect two different networks, especially a connection to the internet. But I think these two options don't make much sense, isn't it? So I'll give you an example. Listen to this very carefully. It would be actually highly relatable to you as well, I think. So imagine your friend wants to come to your home to collect some books. He knocks at your door, and then you open the door and you allow him in, and then you hand him the book that he wanted, and your friend actually leaves the house, and then you close the door. Now I would ask you to replace your friend to be the API call or the network call, your friend's house to be a public network, and your home or your house to be a private network. Then your house door is the gateway, which allows public access to your private network space. So if I ask you, if you never opened the door for your friend, would he be able to get inside? No, the answer will be no, isn't it? He will never be able to get inside if you never opened the door for him. So tell me, what is a gateway? So it's a node that acts as a gate or doorway between two networks. Having said that, just for now, please don't combine both APIs and gateways together to form the API gateways. Have some patience, we'll have a discussion on this very shortly. So now let's design a simple web application based on the pickup truck architecture that we had, and let's understand what could be the possible actions that we can have with REST APIs. So a traditional web service or web application has a user interface, isn't it? And the URL resource for the actions that we want to perform on the application. And each functionality has been divided into multiple microservices. So we have the login service, the inventory, the user data, and we also have the booking service. And for the transaction, we have the payment service and the report generator as well. And for the overall data storage, we have the database service as well. And these microservices are written in Python and are hosted as a part of the deployment on the local server. And we have all the REST APIs to perform the necessary actions and handle the request. So we have the post call where it actually creates the login for us, and then we have a post call where it actually creates the request. Then we have a put where it actually updates the job ID. Then we have a delete which actually deletes the job ID, and we have a get where it actually gets the report for us, like /pickup/update123 being the job ID /reports. There is one more get for us to actually retrieve the data, like get pickup update /123/data. Okay, so if suppose I have booked the truck and I just want to see the information, this API will be used to actually access the data that I have for that particular request that I have made. Okay, and if we transition the same to AWS, we host our services on our EC2 instances and we shift the database to EC2 as well. In both the cases, it fits the requirement as these are well-to-do services and they are effectively managed. And the developers have written all the code to provide us with the APIs, and they will keep on writing code and upgrade the frameworks to show that they are very hardworking and they are compliant to the standards of REST API services. Everything is very good. But what if I tell you that these services and API endpoints can be simplified to an extent that you only have to tweak them once in a while to manage the API and the services, and they will take care of themselves? Would you believe that? If not, think again. I wasn't bluffing. I was serious when I said we will change all of that with a single entity, and that's our AWS API Gateway. And that is how we will change it. So now the developers write the code for the API in AWS Lambda or EC2 or wherever possible. We create our API endpoints at API Gateway, which acts as our trigger points to communicate with the backend services that we have as a part of our Lambda or EC2 code. The user actually doesn't have to access the Lambda or EC2 directly. It can straightaway make calls to the API at the API Gateway and get the response back. It is as simple as it can get. No need to write additional code for the URL resource routing, and you have your API endpoints. It's that simple. And now we have replaced all the get, put, post methods that we had previously with the APIs at API Gateway, and it will work the same way it did before, but it has been upgraded to be more resilient and tolerant. Ignore my parrot in the background. So API Gateway is a fully managed service that makes it easy for developers to create, publish, maintain, monitor, and secure APIs at any scale. It may not be your conventional gateway, but sometimes you might think, why is it called an API gateway? So as I mentioned before, this service also sits in between your users and your services for all the API requests like HTTP API, REST API, and TCP APIs as well. Okay, so now let's get some more details about API gateways. So AWS API Gateways is one of the most important service of AWS with respect to the exam and to your journey as an AWS user or developer or architect. So if you get time, please read the documentations as well. And moving on, with AWS API Gateway, you get an interface with AWS to create your own APIs without writing any additional code. And you can securely publish them so that it gets exposed for the users to consume. You can maintain the state or the version of the APIs as well, and you can as well monitor the traffic or the load and the way it's performing using the tools that are given by API Gateway. So API Gateway is a managed service, as it is already written here, and it is a managed service by AWS. So feel free to use them as per your needs. You don't have to maintain anything for API Gateway. You pay only for what you consume. And with API Gateway, you can create HTTP APIs, RESTful APIs using HTTP, and WebSocket APIs as well. So now you got the point. Why did I stress on these three types of APIs? So API Gateway also supports containerized and serverless workloads, and it supports web applications as well. So if you are using ECS to host your application, then also you can make use of API Gateway. And API gateways have other provisions as well for traffic management, for cache support, authorization and access control, performance throttling, traffic monitoring, and API version management as well. And with API Gateway, there are no minimum fees or startup cost. You pay for the API calls you receive and the amount of data transferred. So remember this very carefully. API Gateway is like a reverse proxy. So if you know what reverse proxy is, you will be aware that reverse proxy acts as a resource provider for the client, but it makes it feel like it has come from the source itself or from the origin itself. And that is why in API Gateway, you pay for the API calls you receive and for the amount of data transferred out. Okay, because it is an API service. You have hosted APIs, so whenever a user or a developer or an application consumes your API, that is the amount of money that you're going to pay. When we think of API gateways, we need to understand that we are thinking of an entity that helps two applications to communicate or talk to each other based on the request and response cycle that we have. So when we consider the type of resources that can be used or that can make use of API Gateway, we have a vast range of resources and technologies that can work with API gateways for the communication and data processing. The first one that you see here is our private application, which could either be hosted on our private VPC or as well in our on-premise solution, and can make use of the APIs that is published at API gateways, actually to communicate with the application backend or services that are hosted on a VPC or on-premise. And next, when we talk about the IoT devices, the log stream data and the analytics data is really important for them, and they can make use of these application servers hosted behind the API gateways that can execute their request and process critical information. The same goes with the web application and mobile and streaming applications, which make use of AWS Kinesis for data streaming. And these applications can also be configured using API gateways when they are working with AWS Lambda or DynamoDB and other services that can help them easily set up their application and be worry free about the throttling issues, because API Gateway will be handling that. And there is one more very important feature that API Gateway provides is API Gateway caching. You can cache your API responses with a TTL. You heard it right. Yes, we can cache the response of the API in the gateway cache for a period of time so that it can be faster to access for the users. And the foremost thing that you have to remember is that with API gateways, you create API endpoints. And these endpoints will be accessed by your customers or developers or users to bind with their applications. Or basically what we can say is integrating it with their applications. So imagine you're working on these applications and you have a provision to create your APIs and put your code on the AWS EC2 instances or AWS Lambda, or have your data stored at AWS DynamoDB, and later on being able to access these functionalities that can help you process the data that you have or help you get the data that you need with just a simple API. Wouldn't that be great? So before moving on, I want to tell you once again that think of API gateways as a simple front door for the applications to access data, business logic, or functionality from your backend services, which can be at EC2 or Lambda or any other web application.